Welcome everybody to today's webinar. Today's webinar will be recorded, and a recording of the webinar along with a downloadable link for the slides from today's webinar will be made available to you within 24 hours. So please watch for that via email. If you have any questions today, please enter them in the questions panel in the GoToWebinar control panel. If I could just briefly have a show of hands if you can hear me and see the screen properly. You could raise your hand in the GoToWebinar control panel. I would appreciate it. Okay, I see some hands going up. Could I get a couple more hands to confirm that you can hear me? There we go. Great. Thanks, everybody. All right. Well, I will now hand the presentation over to Dennis, who will talk about microservices architectures on top of Apache Ignite. Dennis?
All right, thanks, Terry. Hello, everyone. My name is Dennis. I work at GridGain Systems, and I contribute to Apache Ignite project. And I've been working on service grid component of Apache Ignite for quite a while. So I would like to share some of my knowledge and make some overview of features and introduce this feature to you and show some use cases and look under the hood of this component. So this will be our plan for today. We're going first to talk about the services and see what they are, what kind of feature they have, and what kind of guarantee they give to you. After that, we will go to use cases and we will see how you can profit by using the services, what kind of outstanding features can make them useful in your applications, and at the end, finally, we will go to details of internal implementation, and we will see how it works under the hood. So let's start with the overview of features and from the very beginning of the definition of a service. So what a service is. The service is a block of functionality that can be deployed into your cluster, into Apache Ignite, right into the nodes that store your data. So Apache Ignite becomes not only the data storage, not only a database, but also a place where your logic can be implemented and can be deployed. The services have their own life cycle. And they can be deployed, undeployed, updated, and this lifecycle doesn't have to be the same as your cluster have. They also have the number of features and guarantees that we will review a bit later. This is the interface of a service. It has three methods: init, execute, and cancel that pretty much speak for themselves. The most interesting part is execute method that is executed in its own thread. So there's some background logic can be implemented there. You can do some housekeeping there, and a separate thread is dedicated to this process. Init is executed at the beginning of the work of the service, and cancel is called at the end. There are different deployment modes that can be used to deploy your service. There are two predefined ones called cluster singleton and node singleton. Cluster singleton is the mode that makes a single instance of a service be deployed in the whole cluster. So one specific node is chosen at random and the service is deployed there. A node singleton is a mode when you have an instance of your service deployed on every node. So if new nodes come to the cluster, then they will have the service as well. And you can change this deployment mode and choose your own way how you want to deploy the service. So you may choose the total number of services that you want to see in your cluster, and also limit the maximum number of nodes, number of services per node. So you can set total count and max per node count, and the deployment will be handled appropriately with these parameters. For example, this specific deployment can be achieved by specifying total count as 4 and max per node count, for example, as 2. And this pattern of deployment is possible under this configuration. Also, there is a very useful feature as failover. If, for example, we can consider a cluster with a cluster singleton service, and if a node with this service fails, then we need to recover from this situation and to deploy this service somewhere else and on some other node. And this happens automatically. So the node is chosen at random. Some different node is chosen, and the service is moved there. So this way, we always have a single instance of a service, even if nodes with them fail. And it turned out pretty useful if you need this invariant that you always have something running in and only one instance of it is needed. Also, remote procedure call is implemented. If you need to call some method of your service remotely, you can define your own logic in your services, and other nodes can call methods of that service object. So if you have this service deployed locally, then just an object of the service will be taken, and the method will be called on that object. But if a remote call is needed, then Ignite under the hood creates a compute job that is sent to a remote node. An invocation happens there, and the result is sent back to the calling side. So for the user code, it even doesn't matter if the node has the service or not. The invocation will happen anyway. It will either send the computation to a remote node, or the computation will happen just locally. Also, in the upcoming releases, the feature as hot redeployment is planned for inclusion in Apache Ignite 2.8. There will be a possibility to redeploy services on the fly. Currently, you need to restart nodes in order to change the implementation of services. So starting from Apache Ignite 2.8, it will be possible to change the implementation on the fly. So now the lifecycle of the grid and of the service, of the implementation of the service, don't need to match. So you can change the implementation just by replacing the jar files with the service, and it will happen on the fly. So these are pretty much all the features that services have, and they turn out to be pretty useful in a lot of use cases. So let's review some of them. We'll start with the simplest one. This one you can find in the Apache Ignite repository on GitHub. In the examples section, you can find the link in the footer. This is a simple map service that implements the following interface. It has 4 methods: put, get, clear, and size. It's just like Java map has, and the difference is that our service will use an Ignite cache to store data internally. This is the part that is responsible for the service, like for the work of the service. Here we can see an init method that is called at the beginning of work of the service. Here the cache is created, and in cancel the cache is destroyed, and the instance of the cache is stored in a local variable of the service object of the implementation. And the business logic looks as just a simple delegation of work to the underlying cache. So like pretty simple and basic. And the usage looks as follows. First, you need to get a service proxy by calling this service proxy method. And you will get an instance of the interface that you defined. Depending on the fact whether you have the service deployed locally or not. Here you will get either the implementation instance, or you'll get a proxy that will handle the invocations to the interface methods, and in the invocation handler, a compute job will be created and sent to a remote node. But from the user standpoint, there won't be any difference whether you have a local invocation or a remote one. You may only notice difference in performance maybe, but otherwise the invocations look just as simple calls to the interface. So here the invocation is either happening locally or it's sent for execution to a remote node. So this example is like to get some feeling of this technology, and let's complicate things a little bit more and review a more complex one. We will look at the search engine service that will store a collection of documents, and we will search for instances of substrings in that collection. You can find this example in my repository on GitHub. The link is in the footer. So let's review what we have there. We're going to have two entities. So first is document, which has its ID, content, and time when it was added. And we're going to need a match, which has a document and a number of occurrences. Match will implement the comparable interface in order for us to do ranging. So we're going to return only the most relevant documents that we are going to find. We don't need the whole collection of documents that we have with this substring, but only a limited set, and we're going to return only the most relevant ones. So to compare relevance of the documents, we're going to implement the comparable interface. This is what adding of a new document looks like. We just generate a random ID, create a new instance of a document, and put it into a cache. So it's pretty simple. And this is what a search looks like. We use a scan query here. So we create a scan query with the predicate that filters out the strings that don't have the substring of the sought query text. We use a scan query for the sake of simplicity here. Ignite has integration with Lucene for that, but like not to complicate things too much, I just used a scan query. So we just iterate through all the collection of documents, filter out the ones that don't contain the query text, and after that we count the number of occurrences of the sought text, form a match with it, and after that insert the match into the collection of results. So that's pretty much all that happens there. So this will be the logic that we're going to deploy into our cluster. So let's fix it and think about like how we are going to deploy it into our cluster, how we are going to arrange the nodes and how it's going to be implemented. Let's start simple and use Apache Ignite as a data storage. So we're going to have one node that will do all the logic with ranging and searching, and Apache Ignite will be used as a database, and it won't have any logic. It will just give the data to the client node. And the client node will also have a REST endpoint that will receive requests from external systems. So let's see what are the disadvantages of such approach. So there are a number of them. Well, the client node is too clever with this approach. REST endpoint is located there. Also, we have searching that happens only on that node. And as a result, it's overloaded with work. So this is a bottleneck. If you see that the performance is not good enough, you can't just add another server node because it won't help. And you'll probably see that the client is the one that has the highest CPU usage. And in this case, you'll need to buy better hardware for the client node. And this is more expensive than just adding new server nodes. So this solution is not very scalable. And also, if the client node fails, then you have a down of service. There is no failover. We need to take care of client node failures and bring them back somehow manually, and it may be pretty tricky. So let's see how we're going to address these issues and how we can change the situation. Well, first, let's move the searching part to the cluster itself and reduce the utilization of resources on the client side. So we can split the work between the server nodes and put the searching logic into a service and deploy it as a node singleton. So the work will be distributed among the server nodes equally, so every invocation will go randomly to one of the server nodes, and like the result will be sent back to the client, and yeah, the kind of load balancing will be happening there. So we will create a text search service and define the methods that we already reviewed previously. There will be add and search. Also, since we're going to make remote calls to services, it's better to do that in batches. So if you have a big collection of documents that you want to add to your database, it's better to form batches of requests and send them not one by one, but some group of them at once. So this is why I decided to add another method, add all, that will take just a collection of lines that need to be added. And this is the code that deploys the service. So this is just an invocation to deploy node singleton with the name of a service and its implementation. So this code makes every node in the cluster deploy the logic that's defined in this object, in this implementation. Now, we still have the issue with the failing client. So if the client fails, then we have a down of service, that because we won't have any REST endpoint in this case. We have the load balancing, but the failover is still not implemented. And why don't we move the REST endpoint to the cluster and make it a cluster singleton service. It will let us have the possibility to redeploy the service automatically when the node with the endpoint fails. So we can create a REST endpoint service and deploy it as a cluster singleton. And this way, we will have one of the server nodes chosen at random, and the REST endpoint will be deployed there. And this way, we don't even need the client node because it doesn't do any work anymore, and we have a spare machine that can be used as a server node now. So there are like a number of advantages in this approach. We can go even further and use the fact that every service is an object that has its own state. So we can preserve something between invocations to the service methods, and we can use it in our example to cache the results of searches. So we can make a field of in our service, and we will store a collection of results of previous requests. So every search will first look in this collection, and if it finds any cached result, it will just return it. After that, we'll go the logic that does the searching, and at the end, if we don't have too many records in the cache already, we will just save it for future calls. This is like not an Ignite cache. This is just a collection stored in a map, and we need to clean it up periodically, because if we have two old results, so then they will be cached and they will be returned all the time. So we don't want it, and we can perform the cleaning in the execute method that will be iterating through the collection of saved records, and the ones that are too old. So this is the check that performs that sees if the record is too old. If it is, then it's removed from the collection, and it happens periodically or with some period. So the collection is not overflown, and the records are not too stale there. Let's see how it works and like deploy a cluster with these services and see how they work actually. So this is the project that I gave you the link to. You can find it on GitHub. So let's see what we have here. This is the interface that I reviewed, and you can see the same code on the slides. And this is its implementation. In init method, we have the creation of a cache, and the most interesting part is the searching. Here we have this scan query, and the add method saves documents to the cache, and add all is more tricky, and it streams the records using a data streamer. Because we have like some batch of records, we can use a more advanced API for batch processing. So data streamer is used here, and this is pretty much everything that happens here. So this is the execute method that goes through the collection of cached results, and it removes all old records. This is the implementation of the service that exposes the REST endpoint. Here you can see that in init method we start a Jetty server. This is where it is created, and this is its configuration. And at cancel method, we stop this REST endpoint, and this is pretty much the same. This is pretty much everything. The most interesting part happens in the handler of requests. So here in handle method, we perform the searching. Search just parses the parameters passed to us from a browser. So here we have a query and limit parameters. And after that, we take an instance of a search service and pass the invocation to this service and return a result. Also, some error handling happens here. So if we pass some erroneous query or something like that, then it's returned as a batch request. So let's start it. Let's start a few nodes. Let's start, for example, 3 of them. All right. I prepared a document that we are going to load there. This is Crime and Punishment by Fyodor Dostoevsky. So this is like the whole theme here. And we're going to load it into our cluster, and after that perform searching of words in this document. I have a node that performs the deployment of the services that we need during work. Here we have like 2 services, the text search service and REST endpoint service. So the text search is deployed as a node singleton, and REST endpoint as a cluster singleton. So we're going to have just one REST endpoint deployed on one of the server nodes. So let's run it. All right, so services are deployed. We can see the corresponding records in the logs. So here we can see that text search service is deployed. Here also only text search service is deployed. And here the text search service and REST endpoint service is deployed as well. So now we can go to loader node that reads the file and inserts the records into the cluster. So here we have like iterator through the lines of the documents, and we use an add all method to load the lines into the cache. So it passes the invocation to the service, and it does it in batches of 1,000 records. So let's run it. So the loading is now finished, and we can see the records in the logs that some invocations have been processed here. And we can go to our browser and perform some searching. Let's, for example, search for the name of the main character, Raskolnikov. Here are the results of the search. So we have like some number of matches, and there is a limit set by default of 5 records. So we can redefine it to a different number, and we can see like the more results. So the service is working. Now let's go to the node that has the REST endpoint deployed. It's this node, the first one, and let's try to stop it and simulate that something bad happens with this node and that leaves topology. So we can see that it failed, and now we have only 2 nodes, and the REST endpoint is redeployed on another node. We can see that it's redeployed here. So the Jetty now works on a different node, but the endpoint is attached to the same interface, so nothing is broken now. Let's search for something else just to make sure that it's working. Another important character of this document is an X, so we can search for instances of an X here. Yep. So the service is working. So let's get back to the slides. So we have reviewed a few examples of work of services and how they can be used. Now let's see how it works under the hood. Now I will be talking about the implementation that was done previously, not that long ago, and this implementation is going to be available in Apache Ignite 2.8. This implementation can be found in master branch. If you're interested, you can go and see it already. So the development is already finished and it's just waiting to be released in the upcoming build. Let's consider a cluster of server nodes and a client that has a request for deployment. The deployment can happen not only from a client node, but from any server as well. But like the client node that deploys the service is the most common one. So let's consider it. And here we have a coordinator marked with a red line. So it's like on the top. So the client node sends the request for deployment, and it has the configuration of this service and the instance of it. So it's sent over discovery to the cluster, and this request passes all the nodes one by one using the discovery protocol. Once a node receives this request, it looks if it needs to deploy the service locally or not, and this is done on every node independently. So every node calculates the distribution of the service, so-called assignments. So every node knows the distribution of the service among the cluster, and this is done without any additional coordination. Once the nodes deploy the services, the results are sent to the coordinator that collects the results, and once all the results are collected, the result is sent back to the cluster using discovery. So the collection happens using a communication protocol, and the result is sent back using discovery. So once this result is received, it means that the service is usable, and now the invocations to this object can happen again. And there are a number of events that are handled during the deployment. Even if half of your nodes are set on fire, it doesn't mean that anything needs to be canceled. So the deployment happens anyway. There are different cases like coordinator failure, a client node failure, and a failure of a node that has the service or not. And all of these cases are handled properly. This is a big piece or big part of the implementation, and all these cases are considered and handled properly. And the failover is implemented as follows. If the topology changes, then the assignment is recalculated, and the similar procedure to the one that happens during the deployment is repeated. But this time the coordinator initiates it, but instead of a client node. So the assignment is recalculated, and if more services need to be deployed, then it happens in a usual way. These are the links where you can find the description of the work of this component. You can find the user documentation or a design document that was used during the implementation. You can also take part in the discussion of upcoming features that are going to be implemented soon, and also the links to the examples. And now I'm ready to answer your questions.
Okay. If you have any questions, please put them in the questions box in the GoToWebinar screen. First question we have is it possible to monitor the service health in the Ignite cluster?
Well, yeah, it's possible to monitor. In Web Console, there is a service tab that you can use to monitor services. Also, there is an API in Java that using which you can get all descriptors of services, like and see where they are deployed. Some additional features like client service failures, like additional events for such failures as like the interruption of an execute method. They're going to be implemented in upcoming versions, but well, currently you can see where the services are deployed.
Okay. Next question. Can we auto-scale the service instances in the Ignite cluster?
Auto-scale. Well, you can define how many services you want to see in the cluster, and there are limits, like total number and maximum number of services per node. So the total count can be set to, let's go to that slide. The total count can be set to some huge number, and if you add more nodes, then the service will be deployed to new nodes. For example, if you have a node singleton, then you add more nodes and the service is deployed there. So this is like the kind of auto-scaling.
Okay. Next question, can we achieve transaction processing within a service deployed in the Ignite cluster?
Well, transaction processing can happen inside invocations of service methods. Like you can work with transactional caches inside service method invocations. Well, if you mean like, can you invoke service methods within a transaction, then the answer is no. Like the invocations themselves are not transactional. Like you can't roll back what the service has done inside the transaction, but the transactions inside the invocation can happen.
Okay, very good. That's all the questions that we have for today. So I'd like to thank everybody for attending today's webinar. Again, we will send out a recording of the webinar as well as a link to download the slides. And please look for that in your inbox. Thanks, everybody, and have a good day.
Yeah, thanks. Bye.